and I will write that integration from 0 to a over 2, from 0 to a over 2. Now multiply the wave functions psi n0 and psi n0. I can write, if you take the complex conjugate of this, it will remain the same. So it will be just 2 over a square root and sine n pi x over a. And then from 0 to a over 2, from 0 to a over 2, our potential, our perturbation is v naught. And then again 2 over a square root sine n pi x over a, right? Sine n pi x over a, and then it will be dx, the integration on x. Now we will have to solve this one because the perturbation is in this range. There is no perturbation in this range. H prime is 0 there. So we are not counting it. We are only counting that region. Now this integration can be solved like, let me first simplify this one. En1 will be equal to 2 over a and 2 over a square root. So square root will be gone. And from 0 to a, what about this one? Sine n pi x over a, sine n pi x over a. So it will become sine square, because v naught here is not any derivative or a function that you will have to apply. So I will write 2v naught here and sine n pi x over a and dx here. So this is our integral now. Now I will have to solve this one. And to solve this one, there is a formula. You can note this one. Integral sine square of ax dx is equal to minus 1 over 2a cos of ax plus cos of ax sine of ax and plus x over 2. This is a formula that you can apply on this one. Sine square of ax dx is equal to minus 1 over 2a cos ax sine ax plus x over 2, and this gives you en1 is equal to 2v naught over a, and now put the values, minus 1 over 2a minus 1 over, now this is 2a. What is a here? What is in front of x is a. Okay, there are two things which are confusing here. So let me make this one as b, because this a and this a is confusing, means they are creating a confusion. So this is 2b cos b x and sine b x x over 2. Now it will be easy. What is the value of b here? The value of b is n pi over a. So this is 2 n pi over a minus 2 n pi over a here, and then cos of bx, cos, so n pi x over a sine n pi x over a, and then plus x over 2, and x is as it is, x over 2, and it is now having the limits from 0 to a by 2. Now look here, I will just put the limits directly here. When x is a over 2 here, so you can simplify cos n pi x over a. When x is 2a over 2 here, then a over 2 n pi and a over 2 here and cos of it. So a will cancel, pi by 2, cos of pi by 2. If n is equal to 1, then cos pi by 2 is equal to 0. So I'm having for the first term this thing equal to 0. What about means whatever this value, but it will automatically become 0 for the upper limit, and this will become x is equal to a by 2. So this is equal to en1 is equal to 2v naught over a, and for the first term it came out is a over 2. So this came out is a over 2. So a becomes a over 4, because this is a over 2 and 2 makes 4. Plus, what about the next limit, 0? If I put x equal to 0 here, sine 0 is 0. So this whole term becomes 0. And x0 here, this term also becomes 0. So it means it is just a by 4 here. And it can simplify with this. A cancels with this, and 2 simplifies with this. So it comes out, the first order correction comes out to be V naught over 2. So what about our energy? Our energy, which is En, is now the unperturbed energy plus the first order correction to this energy. The unperturbed energy, whatever the value of it, we have already derived this one, is En0, that value, plus V naught over 2 here. And this was the perturbation which was produced in it, and that perturbation we have derived that it caused a change in the energy. Clear? Keep in mind one thing, that this is always an approximate sample because there may be other terms. So we are only finding up to this one. Other correction terms do exist. Now we will find the first order correction to the wave function, and the first order correction to the wave function is that we will find psi n1. And in order to do this thing, again I will go to the first order equation, and that equation was h0 psi n1 plus h prime psi n0 is equal to en0 psi n1, en0 psi n1 plus en1 and psi n0. En1 I have already found, en0 we know from the previous solutions, psi n0 we know from that, and psi n1 we will find out. So it is here and here. So what I do, I just switch this one here in order to make this one is h0 minus en0 and psi n1 is equal to minus h prime. I will move this one here, h prime psi n0 plus en1 psi n0. I have just shuffled them, and now I can further write them as this is equal, psi n0 I can take as common, so minus h prime minus en1 and psi n0 is common from it. So I have this is the equation. Let's say I call this equation 1. And now what is my job? My job is to find out psi n1. So I will have to get rid of the additional terms here. And in order to get rid of the additional terms, let me write this psi n1 in the form of other wave functions, like orthonormal set of wave functions. Let me write this is a complete set psi n1. I can write it like this: psi n1 is equal to the summation on n, and I will explain this one. M is not equal to n, and Cm n psi m0. Can I write it like this? Because consider this one psi n only. Now psi n can be written in the form of other wave functions. These are orthonormal set of wave functions. Like this is a unit vector, and this is the, in a vector space we write like r is equal to x in I plus y in y in j plus z in k. This is the coefficient or the magnitude, and this is the direction in a vector space. Here, these are the orthonormal sets in the Hilbert space. They are just like unit vectors of the vector space. And the coefficient. The coefficient mod square was giving us the probability, if you remember, the probability or density of this one. And if I do integrate this with the dx or with the dr, then it gives us the probability. Now, why I am not including in the summation, like the summation is on m. So m will be equal to 1, 2, 3, 4, and so on. What if I include the value n? So it will become Cn and n and Cn0. And you know that if psi n1 is the solution of a given equation, then psi n1 plus alpha psi m0, let make this n, psi n0, any other in that set, because psi n0, psi n1, psi n2, any other set in that one for any constant value of this alpha will also be the solution of that equation, as they are linear combination. So if psi n1 is the solution of that equation, then psi n1 plus alpha time this will also be the solution of this. So that's why we exclude this thing, that we don't want any redundancy. The numbers are not to be repeated. M is a number, n is a number. N we have taken as a specific number out of it. Like they are 1, 2, 3, 4, 5, and we have just taken 3 out of it. So I will write psi 3 in this one. So you can take any out of this one. And now I will just, whenever we don't know a wave function, we can write it in the form of a linear combination, orthonormal sets, coefficient multiplied with the orthonormal bases of the Hilbert space. We have already done this thing probably in chapter number 3. So I can now write, I can go back to the equation, and this is H0 minus En0, and for psi n1 I can write summation on m. This one value is not counted, and Cmn psi m0 is equal to minus h prime minus En1 psi n0. So I have just put the value here, and now if I will apply this H0 on this one, then what will happen? If I apply H0, means the unperturbed Hamiltonian on this one, summation, or let me just do it exactly on this one, H0 on psi M0. What this will give me? This will give me the energy EM0 and psi M0, as I have already done. Means psi N0 or M0, this is just an index, right? Like 1, 2, 3. So H0 on psi M0 when operates, it is the unperturbed Hamiltonian unperturbed wave function. It will give you the unperturbed energy into that wave function. Clear? So now I can write this one, that if this thing will be operated, and when this will operate on it, En0 on this one, it is just a value. So it will be just like it, and I can write that now for all the terms that are here, summation on m not equal to n, and then the very first term will be em0 minus en0, and this will be cm n psi m0. What we have done, we have just operated h0 on this one and then wrote the result in a compact form, em0 minus en0 as it is. And then this thing is equal to psi minus the same h prime minus en1 psi n0. And now I will have to get rid, because what I want the first order correction to the wave function. That is my job, to find out psi n1. I wrote psi n1 in the form of cmn psi m0 as a linear combination of it. Now what I will do, I will just calculate this one, and in order to calculate this one, let me multiply this thing and integrate, multiplying and doing the integration by psi L0. Now psi L0, and of course the conjugate of it. Now this psi L0, when I will do multiply on this side as well as on this side. Now m is a number 1, 2, 3. N is a number which is also running 1, 2, 3. We have a specified number for this. And L is also a number 1, 2, 3. It is also an index. I'm just writing them in different in order to differentiate between them, that these indices are not the same, they are different. So I'm just multiplying it with another index here. So it will be equal to En summation on m for not equal to n, and then En0 em0 minus en0 is then cmn, and then what it will be, psi m0, this is in the kit and this is the conjugate, so it's in a bra, and it is here psi l0 and psi m0, right? The wave functions will get multiplied, and this thing is equal to minus and psi L0 H prime psi N0, minus minus become plus here, and En1 En1 and psi L0 and psi N0 here. And now look here that we are having this one is delta LM and this one is delta LN, because L and N indices, if L and N are the same indices, then this will be 1. If they are not the same indices, this will be equal to 0. Similarly true for this one as well. And now I can write, because what I'm going behind this CMN. If I find this coefficient, I will put this coefficient here in this one, and I will find psi n1 in terms of psi m0. So I'm just behind this coefficient in order to find out this one, and this will become equal to delta, this is summation on m not equal to n. So sigma m not equal to n and em0 minus en0, and this is cmn delta lm is equal to minus psi L0 H prime psi N0 plus En1 and delta Ln.